Rail transport in Europe is changing. Faster connections, more consideration for the environment, even better safety. Those are the visions. Thanks to us, in some places they are already reality. We have provided an important contribution to making European rail transport fit for the future. Austrian Federal Railways commissioned us to conceive and design all the energy, information and communication systems on the new Lower Inn Valley Railway. Safe, durable and cost-effective. As a full-service provider, we mastered the whole of this challenge. No ifs, no buts. The new sections of line between Kundl and Baumkirchen, they're part of the planned Trans-European Network Line 1. This high-speed rail corridor will run from Berlin through Germany, Austria and Italy, 2,200 kilometers to Palermo. The Lower Inn Valley section is 41 kilometers long and runs mainly below ground. This is the northern approach to the new Brenner Base Tunnel. Trains reach speeds of up to 250 kilometers per hour here. We have precisely planned and completed the energy supply and communications infrastructure on these sections. Moreover, it was also our job to install the overhead contact wire. Special demand of the specification, extreme precision, to keep material wear and maintenance costs as low as possible during later operation. Our engineers and technicians fulfilled that demand. A total of almost 70 kilometers of special overhead contact wire now stretches through the tunnel and powers the trains at top speed. Transmission lines. They carry the energy through the Lower Inn Valley, the same energy that powers the systems on the new railway. The power is handed over in 5 service buildings, then distributed from 25 medium voltage stations to a total of 72 service buildings directly connected to the tunnel. To make optimum use of the energy, we've developed a detailed, well-thought-out system. We installed several switch systems and transformers in series. They reduce the voltage, first from 30 to 10 kilovolts, and then down to 690 volts. From this point, pumps, fans and firefighting water systems are supplied with energy. As early as from this point onwards, we've safeguarded the systems with an emergency power supply. Gas sensors prevent further dangers, just like smoke detectors. We've installed and carefully tested them in every room. Fire, for example, can be detected and tackled early, before the situation takes a dramatic turn. Back to the energy flow. In the next stage, a transformer with a glass core reduces the voltage again, from 690 to 400 volts. With this specially designed transformer, the demand, or as the electrical engineer says, the power loss, can be further reduced by 1/3 compared with a low-loss transformer. The same quantity of energy could power a detached house for a whole year. At this point, all sorts of lighting systems are connected. For example, in rescue areas, on escape routes, or in service rooms. We supply other important components solely from an independent power supply, like electrically operated emergency exit doors, loudspeakers, and the illuminated handrails in the tunnels, to name but a few. We designed and built this complex one-off system to be protected against almost every conceivable source of disruption, to meet the precise requirements of our client, with the help of our know-how and experience. As you would expect, these systems ought not to be accessible by just anyone. A sophisticated access system allows only authorized persons to enter the rooms. "260 kilometers of cables were required to implement this concept. Not only power cables, but also optical fiber cables to carry data and information. To create a robust communication system was a further key aspect of our task. Communication is hugely important for the smooth operation of railways like this, in normal circumstances and in emergencies. GSMR radio networks are an essential requirement for the safe control and management of high-speed trains. Rescue services also depend on reliable communications in the event of an emergency.
Frage, wie ist die Lage im Tunnel?
With breathing apparatus radios and Tetra systems, we have created the necessary framework. Underground, all connections are made through a radio cable, in combination with 50 above-ground radio masts. For crisis situations, we also installed emergency communications columns in the tunnels. A total of 256. Special telephones are available here. They are connected directly to the control center. Reason? The quicker the danger can be discovered and reported, the more efficient the reaction. All the information collected in the tunnel is transmitted over the 240-kilometer-long network of optical fiber cable, at a considerably higher speed and bandwidth than with conventional cables. Data is combined and distributed in telecommunications cabinets designed by us. They also relay conversations, information, and data to their destinations. In some of the telecommunications cabinets, we have installed extra smoke extraction systems to allow any fires in these sensitive areas to be detected and dealt with as early as possible. However, should a fire break out, there are 10,400 individual fire barriers as well as other devices to prevent it from spreading uncontrollably. The complete system is connected to the Austrian Railways Regional Control Center at Zöll near Innsbruck. Events on the line are fully monitored from here. The staff have all the necessary information on operating status and system response to controls right before their eyes. Any malfunctions are immediately apparent. Countermeasures or rescues can be initiated and coordinated without delay. This system is one of the first of this size. This is possible only because we have delivered the complete package. As a full service provider in the fields of energy, information and communications on the new Lower Inn Valley Railway. With our specialist knowledge and commitment, we've helped to equip railway transport in Europe for the future. And of that, we are proud.